So hi all, in this video we'll be seeing about encoder. So first coming to the block diagram. So here we are taking a 4 cross 2 encoder. So it has 4 inputs and 2 outputs. And basically when all the input bits are 0, the output will be 0 0. And when it is like 0 0 0 1 double 0, based on that this will be 1. And in case this is 1, so this will be 2, and when this is 1 this will be 3. So basically, we're trying to encode the information into a smaller pieces. So this can be very useful during communication, and we don't want a lot of wires actually. So here we see that there are 4 wires, which is reduced to 2 wires. Basically, we're representing this complete info into 2 wires and sending it over a long distance. And at the other end, the receiver end, we'll kind of decode it and uh, again get it back in this form in which we had given it in the input side. So yeah, when this is 1, I will get it as 0 0 here. When this is 1, this will be 0 1, and when this is 1, this will be like 1 0, and when this is 1, this will be 1 1. So this is about the kind of truth table and the block diagram of encoder. Now we'll move on to the actual coding, Verilog coding, and so on. So now coming to the Verilog coding, right? So this is a module for the encoder. We'll have basically one input which is which is a 4-bit, because this is a 4 plus 2 encoder. So output is 2-bit. So yeah, so we are making use of small always block here. So since this is always at the rate of star, so this will be implemented as a combo logic. And so here we are making use of the case statement to implement this encoder. So this is based on the input. Based on what is the value of input, we will give the output. So when the value of input is 0001, and then in that case the output is 00. When it is 0010, it is 01, and 0100, it is 10, and 1 all zeros is 11. So depending on which bit, so here the 0th bit is high, so it is 0. Here the first bit is high, so it is 1. Here the second bit is high, so it is 2. And here the third bit is high, so the value is 3. And we keep the default value to be 00. And we end case and give it as end and end module. So we need to have proper syntax here. So always here we have start with the begin and end here. Same way for the case, we start with the case and end case here. And for the module, we start with the module here and end module here. So these are some things we need to take care while doing with the Verilog coding. So this is about the design of the encoder. Now we move on to the encoder test bench. So here we see that it is we give all the inputs are given as reg and output is given as wire, and we are doing the instantiation here. So yeah, it is in and out is out, and so here we are giving the initial module where we are so these are all display lines. It doesn't have any much impact, just for the sake of presentation. Here we are giving the input value as initially 1, and then after 10 units of time we are changing to 2 3 we're changing it to the corresponding bits to 1, and so on. So, and we are giving some invalid cases also, and seeing here we are making giving a 0 and 1010. So in this case, ideally it should know what is the value, right? So default case is no, the output should be 0. So then we are trying to check those things, those aspects as well when you're trying to see it in the waveform. So let us see how these actually get into the waveform here. So once this is fine, so we'll do the so I think the dollar finish is not required, so we'll just comment it off. Now we will do the compile stage. So basically, vlog is the command to do the compilation of the Verilog files, and then we do the we'll start with the simulation, then go to work, and here we need to find the exact instance name. So we'll just see it from here, the module. So it is tb underscore encoder 4 cross 2 is the module name that we need to search here. So this is the one, right? So then we give OK, and then it does the simulation here. So now we have got the simulation. Now we will add wave to basically add signals in the wave. So if you see here, now it is currently there is no data here. So come back to this wave, and then we give the simulate and run minus all. So 100 is for 100 units of time. So run all is for the entire duration of how much ever you are given. So continue is to, like, once we stop the simulation, to continue with the next simulation, and run next is like we are doing it in incremental phases. We give run next. So now we are going to give the run minus all option and give no for are you going to finish it. So now we'll just no, minimize maximize the. So here we see that the first case is the input is 1, the output is 0, and in case of this, the this is the second, the first bit is high. The LSB first bit is high, so we are making it 1. The LSB second bit is high, it is 2. The LSB third bit is high, it is 3. So, and in this, these are the invalid scenarios. In this case, it will be 0. So this is a clear representation here we have got of the encoder here, and we have seen it in the waveform as well. So these are all multi-bit, so these are all clubbed together. Here we can, when we kind of collapse or expand this, we can actually see bit by bit representation of these as well. So thank you. This is what I had about encoder.